Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19. But it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. So angles on a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared. And the force is given to us in the question, so what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometres and I want to convert it into metres, then we know we just times it by 1,000. So 2 kilometres is 2,000 metres. But if I have something in kilometres squared and I want to convert it into metres squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometres squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds, so we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all. And that's what we call an outlier. So we know that these are going up in 2s. So this will be 28. So the x-coordinate will be 28. And this will be 19. So our coordinate will be 28, 19 for our outlier. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom, added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6's go into 15? Well, we're first of all going to have 2 whole ones, and how many left over? There are going to be 3 left over. Now, 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line, and then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one, and the bottom 2 angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom 2 angles in an isosceles are always equal, so that must be 79. Now we've got 2 of the 3 angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. To find the median, we need to have all the numbers in a list from smallest to biggest and find the middle num. Now, we can't do that when we're using a table like this, or it's not very practical to. So we need a kind of different strategy, and the way we do it is to use a simple formula to find the position of the median. Now, the median will always be in the n plus 1 divided by 2 position. So we need to find out what n is, and we do that by adding up all the frequencies there. So let's add those together, and you get the sum of f. So those add up to 15. So if you do 3 plus 4 plus 2 plus 1 plus 5, you get 15. And so we've got 15 plus 1 divided by 2. 15 plus 1 is 16, divided by 2 is 8. So the position of the median is in the 8th position. Now, to easily find out which group, because it's asking for the class interval, which is just a fancy way of saying a group. So it could be this one, or it could be this one. To easily find out which group the median is in, what we do is a quick running total. So what I'm going to do is add up the frequencies as I go along. So we've got 3 there. 3 plus 4 is 7, plus 2 is 9, plus 1 is 10, plus 5 is 15. And then what I do is just convert those into 3rd, 7th, 9th, 10th, and 15th. So what those numbers are the last time that a number is in that group. So we've got 3 numbers that are in the group 10 to 25, and the 3rd one is the last number in that group. The 4th one, therefore, will be in the 25 to 40 group. So we're looking for the 8th one. Well, the 7th one is the last one in this group. So the 8th one will be in this group here, as well as the 9th. Then the 10th one will be in the next group. So when it asks for a class interval, all you need to do is copy down exactly what the group is. So it's 40 to 55. And don't ever write down 40 to 55 or anything like that. Always copy it exactly from the table. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power of 16 times 9 to the power of 46. Now, when you have 2 powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62. So it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between 2 powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40, we just take away the indices. So it'd be 62, take away 40, which would be 9 to the power of 22. So our answer is 9 to the power of 22. So I'm going to write this question out a bit bigger, just so we've got a bit more room. And we're asked to solve. So what we're going to do with this is we're actually going to start by putting our solving lines in, and we're going to try and figure out what we do to get x on its own. So we're going to start by subtracting 9 to both sides, and so that will leave us with the 10x squared on the left hand side and then 250 on the right. Then we're going to divide by 10 both sides, so we've got x squared equals 25, and then we're going to square root both sides. Now, this does give us 5, but it also gives us negative 5, because minus 5 times minus 5 is also 25. So our two solutions are 5 and minus 5. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A, and we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be minus 4, 1. I'm going to write this out just a bit bigger so we can see what's going on. And there are loads of different methods for expanding brackets. I'm going to use smile and rainbows. So smile there, rainbow there, and I always put a little notch here to remind me to times it. So we're going to do 4 times 8, which is 32, and x times x, which is x squared. Then we're going to do 4 times 3, which is 12, and x is just there. So when we expand that, we get 32 x squared plus 12x. When finding a sample of people, you want everyone in the population to have an equal chance of being picked. So in method 1, the fact in a lifestyle magazine might bias the people reading it, because there's groups of people that don't read lifestyle magazines. A poster up in the gym, again, there's groups of people who don't go to the gym. And midday in town centres, well, it might be on a school day, or it might be that you are skewing your data towards retired people. There's lots of reasons why a certain group of people won't be at a town centre at midday. The only one here that gives everyone an equal chance of being picked is this one here. Okay, so picking people randomly from the electoral roll. There are some groups of people who might choose not to be on the electoral roll, but looking at the 4 methods, this one is by far the most fair sample. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. A frequency polygon is like a line graph. In fact, it's a type of line graph, but it is when you have the data in a group. So we've got the data here as a group of 0 to 80. So there are 11 at 0 to 80, and then 18 at 80 to 160, and 6 at 160 to 240. Now, where am I going to plot this? It will involve putting a cross somewhere on this graph. And it would seem unfair if I put it all at 0, and it would also seem unfair if I put it all at 80. So what we do is we find the midpoint, the halfway point between 0 and 80, which is obviously 40, and we plot our coordinate there. So it seems to be going up in 2s, so it would be there. So that's at 40, 11, the coordinate. Our next one, we plot at the midpoint again, which would be 120, and it's just halfway between 80 and 160. And it's 18 high, so it'll be up here. And then the final one is at 200, and it'll be 6 high, so 200 is halfway, and we're looking at 6 high, so it'll be here. Then when you're done, you need to join them up with straight lines. So I'm just going to get my ruler, join them up, perfectly straight lines, and there we are. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. Factorizing is the opposite of expanding. So instead of removing things from a bracket, we're actually putting them in a bracket. And so we're going to start off by just putting the bracket down. And we're going to think, well, what can we put on the outside? So we look at the 20x squared and the 35x. And we first of all think of the number. So we're looking for the biggest number that goes into 20 and 35. Essentially, its highest common factor. Well, that's going to be 5. And then we look at the letters. So we look at the most amount of letters we can divide out. Well, this only has an x here, so it's just going to be an x. Then what we're going to need to ask ourselves is 5x times what is 20x squared? Well, 5 times 4 is 20, and x times x is x squared. Then to get the second term in the bracket, we ask ourselves, what times 5 is 35? Well, that's going to be 7. And what times x is x? Well, we don't need an x on the end of that. 5x times 7 is 35x. And you can actually expand that, and you can use any method you want, but I'll use smiles and rainbows. And so we're going to do 5x times 4x, which is 20x squared, and 5x times 7, which is 35x. So our answer will be 5x brackets 4x plus 7. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. In this question we have a right angle triangle and we know two of the sides and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. and so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12, and the 13 we've just found. When you do that, you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9/15. And therefore the property of female is 1 minus 9/15, which would be 6/15. Male on the second bus is 7/15. And so female would be 8/15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start, and then this line again. Okay, so looking at the fractions along the way, it's 6/15 and 8/15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome would be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6/15 times 8/15. So 6 times 8 is 48. And times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4. And that will give you 16. Is it 4? No. You can divide top and bottom by 3. And that would be 16/75. So either 48/225 or 16/75. Something we know about rectangles is opposite sides are equal. So these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I can pick the 2x plus 3y equals 41, and just substitute the value of x in. So 2 times, instead of x, it's times 10, plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93. So we know we've got it right. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8 w to the power of 10. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times top and bottom by 3, and so it would be 3 brackets k plus 1 over 45, and the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together, and I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4, and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7 over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. This question is the same as questions you get where you've got y equals 8x squared and you've asked to find what y is when x equals 3. The questions are exactly the same, but instead of y we write f of x, and this is saying that the function is 8x squared and we want to feed in the 3 into the function. So it's going to be 8 times 3 squared, and 3 squared is 9 and 8 times 9 is 72, so the answer would be 72. We're going to first of all get x equal to the 0.151151 blah blah blah, and what we need to do is we need to pull all of the recurring numbers in front of the decimal point, or at least one instance of them. So I need to times it by 1,000, so we're going to do that, times it by 1,000, and we'll get 151.151.151 blah blah blah. What we're going to do now is we're going to subtract going downwards. So 1000x take away x would be 999x, and then 151.151.151 etc. take away 0.151151 etc. will just be 151. Get our solving lines in, because the next thing we're going to do is divide both sides by 999. And so we end up with x equals 151 divided by 999, or over 999. And that's our answer. So we've got to factorise the quadratic first, and so we'll end up with quadratic equals 0, but we've got to figure out what it's gonna be. So we multiply the coefficient of the x squared with the number at the end, and that gives us the product that we want, so that would be 90. And then we look at the coefficient of the x, which is 47, that gives us the sum that we want. So we want two numbers that add together to make minus 47, and times together to make 90. Now something you can do is quickly do the factors of 90 and see which ones add together to make minus 47. They both need to be negative, otherwise there wouldn't be a positive product and a negative sum. So two negatives, it would be minus 2 and minus 45. I think that's right, yep, looks good. And so what we're going to do is write the expression, but instead of minus 47x, we're going to do minus 2x minus 45x, and then plus 30. I'm just going to focus on the expression, so I'm going to ignore the equals 0 for now. Okay, so what we do is we look at this part, and we look at this part separately, and we just factorize it linearly, so it would just be an x on the outside, 3x minus 2. This minus needs to go on the outside here, so it would be minus, and then, was it 15? And then that would be 3x, and this needs to be negative to make that positive 30, and that would be negative 2. And then we've got our repeating bracket here, so that would be 3x minus 2 in the second bracket, and then we've got this x and the minus 15 on the outside. So x minus 15 has its own bracket. So we know that it's going to be x minus 15 and 3x minus 2. Then we get this, and we get it equal to 0 and solve it. Get our lines in. Plus 15 both sides. So we get x equals 15, and that is one of our solutions. Do the same thing to the other side. Get it equal to 0. Solve it. by adding 2 to both sides. So that would be 3x equals 2. Then we need to divide by 3 both sides. And a way we can write that is as a fraction, so 2 over 3. So our second solution is 2/3. So looking at the graph straight away, we know that the y-coordinate of point A is 0. And we're told that it's y equals tan x. And you just need to know the graph y equals tan x. And if you know the graph, we know that that will be 180 degrees. We know the point at which both of these lines will be going towards would be 90. This point here will be 270. And so therefore this point will be 360 degrees. So it's going to be 360, 0. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got 2 radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagrams 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got 3 of the sides, we can work out the last one. So angle DOB is going to be 360. Take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB. But I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead. And we've got 3 of the angles, 1, 2, 3. And we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know. So the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. So we can see that there are 8 squares in the first bar, and that represents a frequency of 4. So if you look at what we do to get from 8 to 4, or 4 to 8, we obviously times it by 2. So we're going to do that to the other frequencies. We're going to times them by 2. And they'll tell us how many squares we'll need. So we'll need 20 squares and then 12 squares. The width of the next bar is 10. And we are looking for, well, if you look at it in squares, it is 1, 2, 3, 4 squares wide. And because we need 20 squares in total, it's going to be 4 by 5. So it's going to be 5 squares high. So up here, I'm going to try and pick a colour that shows up a bit better. There we go. And we've just got to make sure that there are 20 squares inside here, which there are. And the last one has to be 12 squares, and it's going to be 2 squares wide, so it's going to have to be 6 squares high. And that will give us our 12 squares. So the frequency is kind of equal to the frequency density times the class width. And I say kind of because it's actually a proportional relationship. The frequency density doesn't have to be that value, it can be twice the value or half the value. But we're going to assume it is because we can check whether it is by the value given to us in the question. So going through each of the groups, the first one is 0 to 10 and it has a frequency density of 0.2. So we're just going to do 0.2 times 10, which will be 2. The next one has a width of 20 and the frequency density goes up to 0.8. So 0.8 times 20 will be 16. And the last one is a class width of 20 and it goes up to 1.2. So we're going to say that that frequency is 24. So if you do 24 plus 16 plus 2, you actually do get to 42. So we know that that is frequency equals frequency density times class width. Okay, now it says to estimate the amount of rocks that were greater than 15 kilograms. So we're going to draw a line up from 15 kilograms. And we're looking for all the values that were to the right of that line. So we know that there are 24 definitely, okay, because all of that bar is to the right of that line. And we've just got to work out what proportion of this bar is to the right of that line. Well, it's 4 squares wide and we're looking at 3 of the squares. So it's going to be 3/4 of 16. So the amount we're looking for, so rocks, is going to be 3/4 of the 16 plus the 24. So the 3/4 of the 16 will be 12 plus the 24, which will be 36. This question is all about completing the square, but we've got to do something first. We have a coefficient of the x squared there, and we want to get rid of that. Whenever we do the completing the square, we need to have just x squared on its own, ideally. So we're going to divide out that 3, and so we're going to have 3 brackets, and then we're going to have the x squared minus 10x, close brackets, minus 11. Then we're going to complete the square with x squared minus 10x. So we're just going to copy in that 3 brackets. And how we do this is we create a bracket and we put the x at the start minus half of the coefficient of the x. So half of the 10 would be 5. Close bracket, squared. Now I'm going to leave that half done because down here I'm just going to, well, across here I'm just going to expand that and show what that creates. So x times x, so that's the same as x minus 5, x minus 5. So we get x squared minus 10x plus 25. So notice here it creates this plus 25, which we've got to deal with. And we deal with that by removing the 25, which we do here. Close brackets, minus 11. So the blue parts haven't changed. The kind of turquoise parts are the completing the square bit, but the minus 25 just removes that 25 that the x minus 5 squared brackets create. Okay, so we need to get that minus 25 outside the brackets. So we're going to expand the brackets slightly. I'm going to leave the 3 on the outside of the x. In fact, let's keep the color scheme going. So we're going to have the x minus 5 squared bit there. 3 times minus 25, it's minus 75. And then we've got this minus 11 at the end. Okay, and we're very, very close to finishing. All we need to do now is sort out the minus 75 and the minus 11. And when we subtract those two, we get minus 86. Now the m part is going to be 3. The p part inside the bracket is going to be minus 5. And the q part is going to be minus 86. We have a plus 2 on the outside of a function, which means that the y coordinates will all just shift up twice, shift up 2 places. So if I look at this point here, I need to shift that up by 2. If I look at this point here, shift that up by 2. The bottom will go to 3, and we're just going through shifting all of the coordinates up, and then just drawing our new function. When you have a minus in the brackets in the function, you're going to reflect it in the y-axis. So we're going to have to reflect this in the y-axis. So we need some kind of understanding of what the sine wave does before it gets to 0, 0. And it starts by going up. So when we go backwards, it actually goes to minus 1 at 90. And then it will go back up, or at minus 90 I should say, then go back up to 0 at minus 180. So what our graph is going to do, because it's reflecting in the y-axis, our graph is going to go down to 90, go down to minus 1 at 90. Now a sine graph normally goes up, but this is going to go down. And actually it's going to look very similar to if it had reflected in the x-axis, but that is not what's happened. It has reflected in the y-axis. It just happens to be identical to if it had reflected in the x-axis. So it's going to go down to minus 1 at 90, back up to 0 at 180, and then just keep going with its cycle. That's not great. We need to cross the coordinates. But as always, make sure you have nice, smooth U-shapes at the bottoms and the tops. And that's more than good enough to get the marks. So we're asked to find f of g of x. And the way composite functions work is that they queue up in order. So the first function we're looking at is the g and then the f. And we're looking at feeding in x into the function g. We're just going to leave function f on its own for the time being. So we're going to feed in that x into function g, and we've got the thing we're feeding in, which actually is just x, and we're taking away 3, so it's just going to be x minus 3. We're now going to feed x minus 3 into function f, and you can see here that it's whatever we're feeding in, which they have put in as x, we square it and we plus 15. So we've put in an x minus 3, and so we're going to square that, then add 15. Expand the bracket, so don't forget that x minus 3 squared is just x minus 3 brackets x minus 3. When you expand that, you get x squared minus 6x plus 9, and then plus 15. And then we simplify by adding the 9 to the 15, and we get 24. And here we're asked to find out what a and b is, or are. A is the 6 there, and the b is the 24 there. So a is 6, and b is 24. Now you might be asking why a isn't minus 6. Well, it actually has the minus in the question, so a is just going to be 6. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.